how do we solve this integral? We don't have a sine x term outside, so there's no clear substitution to make. But when we have a square root, it's nice to be able to represent what's inside the root as something squared, because then we'll get rid of the root and we'll only have whatever's inside left to integrate. Here we have 1 plus cosine x inside the square root. Can we rewrite this as something squared? We know that the cosine squared term appears in the double angle identity. Now we have cosine x, not cosine 2x in the integral. So let's replace x by x over 2. This result is what some people like to call the half angle identity, but I like to think of it as the double angle identity for a specific input. Now, if we take 1 to the other side, then we have an expression for 1 plus cosine x in terms of cosine squared. So let's replace it by 2 cosine squared x over 2. We can take the root 2 outside because it's just a constant. And now we're ready to cancel the root with the power. But be careful. The square root of x squared is not equal to x. It's actually equal to the absolute value of x, because x itself can be negative. So really, we have to put the absolute value around the cosine x over 2. The interval we're integrating over is from pi over 3 to pi over 2. We know that cosine x over 2 is positive on this interval. So only now can we remove the absolute value. The integral of cosine x over 2 is simply sine x over 2, but we have to divide by 1/2 for the chain rule in reverse. And then dividing by 1/2 is like multiplying by 2. Now we apply the bounds, pi over 3 to pi over 2. That will give us sine pi over 4 minus sine pi over 6. Now we know sine pi over 4 is root 2 over 2, and sine pi over 6 is 1/2. So we can combine the fractions. The 2 outside the brackets will cancel with the denominator of 2, and then we can distribute, which results in 2 minus square root of 2. And that's the final answer.